The origins of artificial intelligence, AI, can be traced back to the 1950s, when scientists first began to explore the concept of creating machines that could mimic human intelligence. At this time, the field of AI was in its infancy, and early research focused on creating simple programs that could perform basic tasks such as playing games and solving mathematical problems. One of the earliest attempts to create AI was in the form of a chess-playing machine. In the late 1950s, computer scientists Herbert Simon and Alan Newell developed the logic theorist, which was able to prove mathematical theorems by mimicking human problem-solving strategies. This was a significant achievement as it showed that a machine could perform tasks that were previously thought to require human-like intelligence. In the 1960s, the field of AI began to take shape with the development of early computer programs that could play games, solve mathematical problems, and even simulate basic forms of human thought. One of the most famous examples of this is the game of chess. In the early days of AI research, many scientists attempted to develop a computer program that could beat a human at chess. In 1957, Christopher Strachey wrote a chess program for the Ferranti Mark I computer at the University of Manchester, and in 1958, Arthur Samuel developed a more sophisticated chess program for an IBM 704 computer. These early AI programs were limited in scope and capabilities, but they laid the foundation for more advanced research in the field. Despite the progress made in the early years of AI, the field was still in its infancy and there was a long way to go before machines could truly mimic human intelligence. However, the early successes in AI research sparked a renewed interest in the field, and set the stage for the many breakthroughs that would follow in the decades to come. The AI winter and the rise of expert systems. In the 1970s and 1980s, the field of AI faced a period of decline known as the AI winter. Funding for AI research decreased, and many researchers turned away from the field due to the lack of progress being made. The main reason for this decline was the lack of progress in AI's ability to perform tasks that required general intelligence, as opposed to specific expertise. However, during this period, a new approach to AI called expert systems emerged. These were computer programs that were designed to mimic the decision-making abilities of experts in specific fields. They were based on the idea of knowledge engineering, where experts in a particular field would provide their knowledge to the system in the form of if-then rules. Expert systems were able to perform tasks such as medical diagnosis, legal reasoning, and financial forecasting with a high degree of accuracy. They were able to provide the same level of expertise as a human expert, but with the added benefit of being faster and more consistent. This led to the development of expert systems in a variety of industries, and they were widely adopted in the 1980s and 1990s. The success of expert systems marked a turning point in the history of AI, as it showed that computers could be used to perform tasks that required expertise, rather than just performing simple calculations or playing games. This success led to a renewed interest in AI research, and set the stage for the next phase of AI development. The rise of machine learning and neural networks. In the late 1980s and early 1990s, a new approach to AI called machine learning emerged. Machine learning is a method by which computers can learn from data and improve their performance in a specific task without being explicitly programmed. This was a significant shift from the traditional approach of AI, which relied on expert systems and rule-based systems. One of the key breakthroughs in machine learning was the development of neural networks. Neural networks are a type of machine learning algorithm that are modeled after the structure and function of the human brain. They consist of layers of interconnected neurons that process and transmit information. The development of neural networks led to breakthroughs in a variety of applications, such as image and speech recognition, natural language processing, and even playing games like chess and Go. Neural networks were able to achieve levels of performance that were previously thought impossible, and they quickly became the foundation of modern AI. The impact of big data, and the cloud? In the early 2000s, the amount of data being generated began to explode, thanks to the growth of the internet, and the proliferation of mobile devices. This led to the development of new technologies and tools for storing, processing, and analyzing big data. The availability of big data was a major driver of the progress in AI, as it allowed researchers to train and improve their machine learning algorithms. The development of cloud computing also played a significant role, as it allowed researchers to access vast amounts of computational power and data storage at a fraction of the cost of traditional methods. The combination of big data and cloud computing led to a new era of AI development, where researchers were able to train and test their algorithms on massive amounts of data. This led to breakthroughs in a variety of applications, such as self-driving cars, natural language processing, and even the creation of AI-powered virtual assistants like Apple's Siri and Amazon's Alexa. The future of AI. The future of AI is looking increasingly promising, with advances in several key areas, including machine learning, deep learning, and natural language processing. One of the most exciting areas of AI research today is in the field of deep learning, where researchers are developing neural networks with more layers and greater complexity. These deep learning algorithms are able to process and analyze data in ways that were previously thought impossible, leading to breakthroughs in applications such as computer vision, speech recognition, and natural language processing. Another area of AI research that is gaining momentum is in the field of reinforcement learning. This is a type of machine learning where AI agents learn by trial and error, receiving rewards for positive outcomes and punishments for negative outcomes. This type of learning has the potential to create AI agents that can learn to perform complex tasks, such as playing games, driving cars, and even making scientific discoveries. The field of AI is also increasingly being used in various industries, from healthcare to finance, from retail to transportation. Companies are using AI to automate repetitive tasks, improve decision-making, and even make new products or services. As AI continues to advance, it is important to consider the ethical implications of these technologies. Researchers and policymakers are grappling with questions about privacy, bias, and accountability, as well as the impact of AI on jobs and the economy. Overall, the future of AI is exciting and filled with possibilities. As researchers continue to push the boundaries of what is possible with AI, we can expect to see more and more applications that will change our lives in ways we can't yet imagine.